Hi again. So today we are going to extend our look at simplifying square roots to simplifying any kind of radical. And this is where my saying math is consistent really comes into play. If you see a different root, a different kind of radical that's not a square root but a third root, sometimes we call that a cubed root, or a fourth root, or really any root, what I'm going to show you today is that if you just do what you've always done with square roots, but change the meaning to whatever root we're talking about, everything else works itself out. Really, you've already learned everything you need to learn in math. We just need to extend it to different situations. So here we go. Again, I have 4 examples on my paper. You may want to get these down in notes of some sort to help you. The first example is the cubed root of 16. So here, remember with the square root, I'm looking for 2 numbers that multiply to give me that 16, 2 numbers that are the same. So if it was the square root of 16, it would be 4. 4 times 4, 2 4s multiply to give me 16. Well, here I'm wondering what 3 numbers multiply to give me 16. Well, nothing does, but maybe there is a number that's a perfect cube that divides into 16 that will help me simplify it. Just like yesterday when we found perfect square numbers that would divide in. This is a cubed root, so I need to find a perfect cube. We're really good with our square roots. Other roots aren't so easy. So off to the side, I'll often make a list of cubes, just so that I have kind of a quick reference. So for example, 1 cubed is 1, so 1 is a perfect cube. 2 cubed, 2 times 2 times 2 is 8. So 8 is a perfect cube. We could say that the cubed root of 8 is 2. I multiplied 2 times 2 times 2, 2 cubed, to give me 8. These numbers get big fast, so let's talk about 3 cubed. 3 times 3 times 3, 9 times 3 is 27. 27 is a perfect cube. 3 cubed is 27. The next one would be 4 times 4 times 4, or 16 times 4, which is 64. And again, they're going to get big pretty quickly. So you start to make a list. We don't need to go any further right now because my number is 16, and the largest number on this list that will divide into it nicely is 8. So like yesterday, I'm going to rename the cubed root of 16, rewrite it as the cubed root of 8, a perfect cube, times the cubed root of whatever's left over. Well, 8 times 2 is 16. Then do what you can to simplify. The cubed root of 8, that's a perfect cube, that's 2. 2 cubed is 8. So the cubed root of 8 is 2, and I can't take a cubed root of 2, so I leave that alone. So again, math is consistent. The process is the same. It's just we need to apply what we've always learned with square roots to cubed roots and fourth roots and others. Let's try a few more. Okay, so here I'm talking about the fourth root, so 4 numbers that multiply together that are the same. Of 48, a to the 9th, b cubed. So I'm combining numbers and letters in this example. Let's think about perfect fourths first. 1 to the 4th. 1 times 1 times 1 times 1 is 1. 2 to the 4th. 2 times 2 times 2 times 2 is 16. Okay, 3 to the 4th is 3 times 3 times 3 times 3. Or 3 cubed, 27, times 3 more, which is 81. And we can stop there. I see that the largest perfect fourth number that will divide into 48 is 16. So I'm going to rewrite 48. The fourth root of 48 is the fourth root of 16 times the fourth root of 3. 16 times 3 is 48. Now remember yesterday with square roots, we took our exponent and we divided it by 2 because it was a square root. Well, here, math is consistent. We'll take the exponent on our variable and divide it by 4. So 9 divided by 4 is 2. Or I could think of it, we broke it up, we subtracted 1 to get it even. I could subtract 1 here and see that I have an a to the 8th, which is 2 sets of a to the 4ths. And then I have 1a left over. It's another way to think about it. b cubed, 3 is smaller than 4, so that's not going to simplify at all. So that's going to end up having to stay under my fourth root. Okay, so just like yesterday, we clean up our mess and we're done. So the fourth root of 16, what number did I raise to the fourth to get 16? 2, so that's 2. Fourth root of 3 is going to have to stay inside the house. The fourth root of a to the 8th. 8 divided by 4 is 2, so that is a squared. Fourth root of a is going to have to stay inside, and b cubed is going to have to stay inside. So there your answer is, careful that that looks like an index, 2a squared times the fourth root of 3ab cubed. Pretty scary looking stuff. It's okay, we'll keep practicing. So let's just do a couple more so you can see how it goes and then practice a little tonight. So the fourth root of 32, I've already started a fourth roots list, so I'm not going to do that again. 16 divides into 32 nicely. So I'm going to rename 32 as 16 times 2. 5 divided by 4, 4 will go into 5 once, so there's one group of x to the fourths inside of x to the fifth, and then there's one left over. And y to the fourth is a perfect fourth. 4 divided by 4 is 1, so that's just going to come out as a y. Do that right away. And now simplify. Fourth root of 16. 2 to the fourth is 16. That's 2. Fourth root of 2 is going to have to stay put under the house. The fourth root of x to the fourth is a perfect fourth. That comes out. X has to stay put. And we pulled the y out before. So the answer to this, simplified, is 2xy times the fourth root of 2x. One last one. Now keep in mind, with the videos, you can pause and try this on your own, or you can follow my steps right through it. There's no right or wrong way to watch the videos and take notes. It's really about you and how you're going to learn this best. What's going to work best for you. Okay, so cubed root of 40, a to the fourth. Well, cubed roots, here's a list that I made earlier of perfect cubes. That might be a great thing to have some of these little lists in your cumulative notes as a reference, and that you can keep expanding on. Maybe later we'll need 5 cubed, and we'll add that in there, or 4 to the fourth, whatever. So here's my list. I have the cubed root of 40. Well, the largest perfect cube that divides into 40 is 8. So I'll rewrite that as the cubed root of 8 times the cubed root of, well, 8 times 5 is 40. A to the fourth, 4 divided by 3 is 1, so there's 1 a to the third that goes into a to the fourth, and then there's 1a left over. So pull out the perfect stuff, leave the imperfect stuff inside. Cubed root of 8 is 2. Gonna have to leave cubed root of 5 in the house. Cubed root of a cubed, 3 divided by 3 is 1, so a to the first, and this cubed root of a to the first stays in the house. That's it. They look a little overwhelming and scary. Give them a try. Try the few on Math Excel, and we'll do lots more tomorrow. Thanks.